All right, so going to wrap up this 4.4 kind of video series with 2 more graphing examples that include a lot of our transformations, so a phase shift and a change in the period. And if you want kind of a formula for this, if we've got a b value and a c value inside the sine function in the argument, in order to figure out the stretch or the period and the horizontal shift left or right, you should always factor out that b value. So inside we'd have x plus, right? When you factor it out, we'd have c over b. So that c over b is going to be your phase shift. So this graph would be a horizontal shift of negative c over b, right? When it's inside the parentheses, we always do the inverse operation. The same thing would happen for cosine going through. So the phase shift is just a horizontal shift left or right, changes the starting position of our sine or cosine curve. So in our 4.4 packet, the first graphing example with kind of a bunch of stuff going on here is sine of 3x minus pi over 2. And we can still go by, way back in chapter 1, we said first, F-R-S-T. So we need to factor to start off. So any x coefficients, we need to factor away from the x. So this would be 3. When I divide pi over 2 by 3, I'm going to get pi over 6. So just writing out a couple of important things about this graph. The first thing is the new period. And that will be affected by any horizontal stretches or shrinks. So we've got this 3, which is really going to divide all of our x properties, all of our x values by 3. So the new period is going to be 2 pi over 3. And this pi over 6 is going to move our graph to the right pi over 6. Right, so that'll be our phase shift. Again, a couple ways you can do this. I've been graphing using kind of this distance between the key point method, but maybe I'll try out another method here that I talked about earlier, and that would be like using our actual key points from the original graph. So my original sine function, I have key points I can use 0, 0, and pi over 2, 1 are 2 key points that we should know from the original parent function. And then I would go back to whatever I'm graphing here, so sine of 3, and I need to look at this factored form and pick out all my x and y changes. So this graph is going to be, remember, PEMDAS order. So first I multiply, and I would need to do a third times our x's. I'm really dividing by 3. And then I would add pi over 6. No change in the y values, so it's set there. And then work out what my key points would be. So this first point would be just pi over 6 when I do my x changes, and then 0. And then this second key point, I'll take my time, would be pi over 6 plus pi over 6. I'm just going to write it as 2 pi over 6 and the same y value. All right. So once I do this, I can see that pi over 6, right, these are both, would be a nice scale for my graph. And I have my first 2 key points. So I'll make like every 2 lines on this graph pi over 6. So I'll do this guy as a pi over 6. So this would be 2 pi over 6, 3 pi over 6. I just usually like to label a couple. 4 pi over 6, 5 pi over 6, and 6 pi over 6 would be pi. Maybe I'll change my scale on the y-axis since I don't need to go so high. And then throwing in my key points. So pi over 6, 0, my first key point. 2 pi over 6, 1. And then we have to remember our parent function, what the sine curve looks like. So that's the first, like going to the mountain, the maximum. Then I would go back to my midline, down to my minimum, just keeping the pattern. I did my key points are 2 lines apart, and all the way up. So at least 1 full period. It looks like that. Sometimes I like to go back to the x-axis, going through. So we should definitely be able, again, to pick out at least a max and min. And this guy we had, 2 pi over 6 is really pi over 3. This minimum point over here would be 1, 2, 3, 4 pi over 6. So 2 pi over 3, negative 1. A nice little graphing method. I really like that kind of 2 key point method to graph, and maybe I'll use that more often on here. But again, lots of methods out there. All right, so I'm going to do one more quick graph on here. You know what? I think I'm just going to erase all this. Do I want to erase? No, I'll make a new one. So start a new slide, grab my picture one more time. All right, and let's see if we could breeze through this one. I'm going to use that same key point method, but maybe you guys try it out on your own using whatever method you like, and then just see if you match up with me. You can fast forward the video, and if something goes off, then rewind and see where things went wrong. All right, so this is the function I'll be graphing. First thing first, I'm going to factor out that pi over 2, and I did not write the function right, so let me erase that. Should be x over 2 up there. All right, now we're looking much better. And now we're going to start by factoring out that 1/2. So I'll get cosine. Can't take it all the way out of parentheses, but just factoring it away from the horizontal shift. So of x plus, when I divide it out, pi over 1/2, I'm left with a pi over 2 in here. And then minus 2 on the end. So a couple good things to note. Now I've got a new midline at -2. I like to start with that, even when I do the key point method. So down here, -2. Didn't quite make it all the way across my graph, but that's okay. All right, no amplitude change, no vertical reflection. So everything else will be y changes or x changes. And they're going to affect two things. Oh, I'm drawing all my lines. So I'm going to have a new period, which would be 2 pi divided by b. b is 1/2, so my new period is going to be 4 pi. Right, which is really nice. So between my key points, I'm going to have pi units, 4 pi divided by 4. I always like to keep that in mind. And then the phase shift, I'm going left pi over 2. So I think pi over 2 is going to be a really good scale for this graph, and a lot of people might just jump right to the graph and graph that. But one more time, I'll do this like key point method. I don't think I've done it with cosine yet. So writing out my changes for the x's, I'm going to have 2 times x, right? First I do multiplication, and then minus pi over 2 for that horizontal shift. And for the y's this time, we'll be subtracting 2 from the y values. So thinking of our original cosine key points, I'm starting at that max of 0, 1, and then going to the midline, which was pi over 2, 0, and applying all of these changes. So this point's going to go to negative pi over 2, and 1 will go to -1. Hopefully everything's going good there. And then pi over 2, 0 would be, I'm going to kind of take my time and write this one out. So we'd have 2 pi over 2 minus pi over 2. So it looks like we'll be at pi over 2, -2. And made sense with what I was saying before. So our distance between the key points is going to be pi. Pi over 2 looks like a good scale, right? I could even do pi, but I wouldn't see those pi over 2's very easily. So I'm going to do every, I don't know, it doesn't matter. I'll do like every 2 lines is pi over 2. I like 2 lines usually. And I'll just label the pi's. And I know the period's going to be 4 pi, so I'm going to need a couple. So this will be 2 pi, 3 pi. That'll be enough to go all the way through. But I'm going to throw one more. All right, and then putting some points on here. So I've got negative pi over 2, -1 right here. And then pi over 2, -2 is on my midline. So notice I've got 4 units between key points. I'm going to count 1, 2, 3, 4. 2, 3, 4. And my amplitude's 1, so just going right below the midline. 1, 2, 3, 4, right, units. Back to the midline. 1, 2, 3, 4 units. 1, 2, 3, 4. There we go. To our max. And that looks like, oh, I didn't count quite correctly. Should be right over there. So my period will be 1, 2, 3, 4 pi. That looks good. And then fill in my graph. And again, being able to pick out a max and a min value, the period of your graph, kind of all that jazz. All right, so there's 2 examples for us. There's one more in the packet for you to try out. You can compare to my answer key, but I'm not going to make another video. And again, come up with a graphing method that works for you. Sit down with me if you need help, and we'll be practicing more graphing in class.